So I'm going to try another kind of a diagram and see if this helps clarify it at all. On the left side, I have a diagram that would illustrate poor repeatability. So the first time I measured the sheet of paper, I got a result here, and the second time here. I have 5 sheets of paper. That's what these numbers represent. For sheet of paper number 2, I got this the first time and that the second time. 3, I got this the second time. I measured that the first time, and so on. So I've got a big variation between repeat readings, but not a lot of variation between the part averages. So when you plot that on a control chart, here's what it looks like. The limits are very wide. These control limits, the width between them is represented by the error between these readings. So the variation between repeated readings is wide, and so these control limits are wide. And the variation between parts is much smaller than the variation between readings. And that is an indication that the measurement error is too great to detect the difference between the parts. Now, in contrast, here's what a good measurement system would look like. The first and second measurements are all very close together. The difference between the different pieces of paper is very large compared to the difference between the repeated readings. These control limits represent the error from repeatability error, and you see they're very close together. And this measurement system is fully capable of picking up differences between parts, because the difference between parts is much greater than the difference between measurements. So here's the difference between measurements. Here's the difference between parts. So hopefully that'll help clarify it.